Hey boys and girls, this is Wednesday's math lesson. It is in your volume 1 book on page 127, and we're going to be beginning our study of fractions. Okay, so today in class we had a chance to get out some tangram pieces and try to make this puzzle piece of a tangram. And when we come back to school, we're going to discuss the fractional pieces of those tangrams, but we're going to wait till everybody gets back before we take those tangrams out again and talk about what size of the fraction is represented in that whole square. All right, so we went over some vocabulary words in class today that we need to talk about. Okay, we discussed what is a multiple, and some examples of a multiple are patterns that happen when you multiply numbers, and it's the number that you end up with. For example, multiples of 2 are 2, 4, 6, 8, 10, on and on and on. And we said that they are infinite. They go on forever. And then we had factors. Now we're familiar with factors because we know factors are two numbers that you multiply by each other in order to get a product. And so when we look at factors of a given number, for example, 10, we want to find all the numbers that we've multiplied together to give us 10. So I know 1 times 10 gives me 10, so 1 and 10 are factors, and 2 and times 5 is 10, so 2 and 5 are factors. All right, and so I can see that factors do not go on forever. As a matter of fact, they are finite. Multiples, infinite, they go on forever. But factors, they are finite, they come to an end. All right, then there's two other terms that we're familiar with, and that is, what is a sum? And we know that that is the answer to an addition problem. And then the answer to a subtraction problem is called the difference. And then we made sure that we understand what a denominator is. And we know the denominator is the bottom number on a fraction. And the denominator tells the size of the piece. So the 3 would mean that the whole unit is divided up into 3 pieces. And then if we put the word common in front of the word denominator, then that just means we're talking about the bottom number, but we're talking about 2 or more fractions that have the same denominator. So they have the denominator in common. And so an example would be in this addition problem, both fractions have the same denominator, so they have a common denominator of 3. Okay, so now we are ready to talk just a little bit about what you already knew last year from fractions in 4th grade. All right, and so here we have a couple of examples of what you might recall from doing last year. So you had to look at 2 different fractions and you had to compare them. And you might have used fraction pieces, or you may have wrote an equivalent fraction. So this would be an example of writing an equivalent fraction so that you could compare them. All right, so in this case here, I might just draw a picture of what 2/3 would look like and shade in 2/3. And then I would draw a same size circle, divide it into 6, and shade in 1/6. And I would be able to tell that the 2/3 is greater than 1/6. All right, and the same thing with 1/4. Since these two have different denominators, but they have the same numerators, I know that the unit fraction 1/3 is bigger in size than the unit fraction 1/4. And I could draw a picture to demonstrate that, to show that I am correct. Since 1/4 is divided into 4 pieces, I know those pieces would be smaller if my pictures were a little more accurate. All right, so I know 1/3 is greater than 1/4. And then you use this method of multiplying by a number on the top and bottom that are the same. For example, here I've multiplied by the number 2. I not multiply my numerator by 2. I multiply my denominator by 2 to get another fraction that would be equal to the one that I started out with. So I know 3/4 is equivalent to 6/8, and I know that because I've multiplied by 2 over 2, which is another name for 1. And we know that any number times 1 is equal to itself. That's the identity property. And so that's what we're using right here on this computation. Okay, so I am on page 128 now, and we're getting ready to do the Are You Ready? So this goes over some concepts that you are familiar with from 4th grade that you're going to need to be really good at as we're working on these 5th grade concepts today. All right, so are you ready? This is page 128. Complete these problems to review prior concepts and skills you will need for this module. Part of a whole. Write the fraction that names the equal part. Then write a fraction to name the shaded part of the whole. Okay, so I'm going to look at this first picture. Each equal part is 1/4. Three-fourths of it, 3 out of the 4, is shaded. In number 2, it asks us about each equal part again. So I'm looking at this and I can see that it's been divided up into triangles, and they are divided up into 8 equal sized triangles. So I know that each one of these would be 1/8. So each equal part is 1/8. The total amount shaded, I would simply count up the shaded part. 1, 2, 3, 4, 5. So I can see that 5 of the 8ths are shaded. Okay, adding and subtracting fractions like these are similar to ones you did last year. Now what you will notice on each of these is they have a common denominator. And so I know when I am adding 3 of the 8ths and 3 more of the 8ths, I will get 6/8. And 6/8 can be simplified to 3/4. And I simply did that. I simplified it by dividing it by another name for 1. Okay, so in number 4, we have 5/9 minus 2/9. Well, if I have 5/9 and I take away 2 of the 9ths, I'm going to have 3 of the 9ths left over. And I know that 3/9 is equal to 1/3. Okay, how do I know that? Because I can divide by another name for 1. Three divided by 3 is 1. 9 divided by 3 is 3, and see that it equals 1/3. Number 5, 1/6 plus 5/6. If I have 1/6 and I add 5/6 more, I know I'm going to have 6/6. I know that any number over itself, like 6/6, is equal to 1 whole. Number 6, if I have 2/5 and I add 1/5 more, I know the sum is going to be 3/5. And 3/5 cannot be simplified. Number 7, 1/3 plus 1/3, I'm going to have 2/3. And 2/3 cannot be simplified. Anytime I have 2 consecutive numbers, for example, like 2, 3, or 3/4, I know that those are reduced to the lowest term. Number 8, I have 4/7 minus 2/7. So if I have 4/7 and I take away 2/7 of it, I know I'm only going to have 2/7 remaining as a difference. And that cannot be simplified. If I have 3/4 and I take away 1/4, I'm going to have 2/4 left. And we know that 2/4 is equivalent to 1/2, so it can simplify to 1/2. And then here's 7/8 minus 5/8, so I'm going to leave 2/8. And I know 2/8 can be simplified because they have a common factor of 2, so I can divide it by 2 over 2. which is another name for 1. 2 divided by 2 is 1. And 8 divided by 2 is 4. So I know that 2/8 will simplify to 1/4. This is called its simplest form. Okay, the number 11. I have 4 ninths. I'm going to add 1 more ninth. I'm going to get 5 of the ninths. Okay, so we notice that when you have common denominators, it stays the same in our sum. In this problem, we have common denominators. It stays the same denominator in our difference. Okay, and then we use this word multiples. So we were talking about multiples today. So the first problem says write the first 6 non-zero multiples. Now they're saying non-zero because they don't want you to put a 0 here first. 0 is a multiple of every number, but it really isn't used for fractions very often. So so we're not going to worry about putting zeros as our first multiple. So we're going to start with, instead of 0, we're going to say, okay, 2, because 2 times 1 is 2, then 2 times 2 is 4, 2 times 3 is 6, and we can see the pattern here, 2, 4, 6, 8, 10, and 12, and I think that's 6. All right, and then we're going to, I'm just going to go down. For 8, okay, these are going to be multiples of 8, skipping 0. 8, 16, 24, okay, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 32, 8 times 5, 40, 8 times 6, 48. 6, the first one's going to be 6, because that's 6 times 1. Then 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30. And 6 times 6, 36. Okay, my first 6 multiples of 9. 9, 18, 27. Now 9 times 4, 36. 9 times 5, 45. 9 times 6, 54. Multiples of 4. 4 times 1, 4. That's my first one. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. And then multiples of 3, 3, 6, 9, 12, 15, 18. Okay, so these are concepts and skills you're going to need in order to do this module. All right, so now we're getting to today's lesson. It's already been 13 minutes. Okay, so in today's lesson, it says we want to represent fraction sums and differences. All right, and so we're going to represent them. So that means we're going to use models to come up with these answers. And so I'm going to use fraction bars to show you how we would come up with these answers. I know you don't have fraction bar sets. You'll make some at school that you can use at home later, but for now I'm just going to show you on my screen, and then we can draw them on your screen, on your workbook. Okay, so we're going to start by marking up our I can statement. I can use a visual model to represent the addition or subtraction of fractions with different sized parts. All right, so what does that mean, different sized parts? Okay, well, we talked about that just a little bit before. When we had to add together fractions that had common denominators, that would be like 1/3 plus 1/3, and we know that would be equal to 2/3. So if I have this equation, 1/3 plus 1/3, that equals 2/3, and we can see that if we put those together, it's 2/3. But if I had different denominators, if I had 1/3 plus 1/2. So what does this equal? 1/3 plus 1/2. Well, they're different size pieces, or they're different size parts. So I'm write the equation for that, 1/3 plus 1/2, but I just can't say 1 plus 1 is 2, and then add the bottom numbers or something and say 5. I can't do that. That's wrong. I just can't say it's thirds, or I just can't say it's halves, because it's not. It's two different things. All right, so this is what we're going to have to do today. We're going to have to rename these pieces. We're going to rename them something else that I can combine. And so that's what we want to learn how to do. All right, so we're going to start with this story, and it's about hiking. And I'm sure you all have been hiking before. You've probably taken hikes along the beach or in the woods, and that's what this word problem is set up on. So we have 4 hikers who travel along the same trail over 2 days. The fraction of the trail each hiker travels is shown. Okay, so we have these 4 kids, and day 1 they went out and walked a part of the trail, and then on day 2 they went out and they walked another part of the trail. Use the data in the table to show 2 ways to represent the fraction of the trail one of the hikers travels on both days. So we're going to pick one of these hikers, and we're going to represent the fraction of the trail that they traveled altogether. All right, so first of all, I want you to think about what we're going to do here. We're going to have to add these together. Now, why would this be an addition problem? Well, because I'm going to take day 1 of one of the hikers' trail that they hiked, and then day 2, and then I'm going to combine them together to get the total. All right, so I'm going to just pick James here. I'm going to pick James. And I'm picking James because he did half of the trail on day 1, and then on day 2 he didn't do quite as much. He only did 1/4 of the trail. All right, so how can I show 2 ways to represent the fraction of the trail that one of these hikers travels on both days? All right, so I have the equation here. The equation would be 1/2 plus 1/4 would tell me the total amount. So I'm going to have to come up with what is 1/2 plus 1/4, and I have to show that. All right, well, I can model it like this. I can say, well, here's a half, and then that's for the day 1, and then I need a 1/4 more. So I need to add these together. Okay, well, I can see it's that long, but what is that going to be equal to? Well, I know I can only combine these amounts if they have a common denominator, which these don't. But I do know that 1/2, if I take these 1/4 pieces and I compare it to 1/2, I know that 1/4 plus 1/4 is the same thing as a half. So I can say, well, let me just say, instead of having a half, let me call it 2/4. And then I can add this other 1/4 and get my total. So I'm picking my 1/2, I'm renaming it to 2/4. Then I can add this other 1/4 to it. All right, so how can we model this? We're going to draw one fractional piece, and we're going to call it 1/2. And then we're going to add 1/4 over here to it. These two have to be combined. I want to know how much is this. Well, I know if I cut 1/4 in this half in half here, if I cut 1/2 into halves like this, each of these would be a 1/4. So I'm going to say that 2/4 plus 1/4 equals 3/4. All right, what's another way I could do that? Well, instead of using a bar model, I could use a circular model like this one. And I want to represent one half. So I'm going to draw a circle and I'm going to carefully cut it in half. I know this much is a half. I'll shade that in. Now I have to add 1/4 to it. I know this is not 1/4. This would be a half. But I do know if I cut across here like this, I know that this is 1/4. So that's my 1/4, and I still have my 1/2 over here. So I want to know how much is this altogether. Well, I sort of gave it away here when I put those lines there. I can see that 1/2 is the same as 1/4 and 1/4. With this on it, I can see it's 3/4. Or I can also say, hey, in this circle, if you have that much of it shaded in, that's going to equal 3/4. Okay, so we have two different models that show how I can combine 1/2 and 1/4. And I could do that same thing for each of these others. They do not have common denominators, so I would have to rename it. I'd have to find a fraction number that I could make it so that it could be in common with this one. Okay, let's go on to the next page. Okay, so this is page 30, and we're going to continue building our understanding about how to combine fractions that are different size parts. All right, so in this little story here, we have a couple of kids that are saving up to buy a tent. Okay, and you know when you have the total cost of something, if you've saved up half of that, you still have halfway to go. All right, and so Jackie saves half of the cost and Marley saves 3/4 of the cost. All right, and I want to know how much do Marley and Jackie save toward the cost of the tent. So that means if I have Marley and Jackie and I want to combine their two fractions of the cost that they have saved together. All right, so when I'm combining things, I know that I'm going to have an addition problem. I know that I need the two parts to make a total. How can I represent this situation? All right, well, I know that Marley saves 3/8 of the cost. I'm going to write my equation first. And I know that Jackie saves 1/2 of the cost toward this tent. So I know that together, if I combine these, I'm going to have how much they have saved toward the total cost of the tent. All right, well, first I'm going to represent this with some fraction pieces. I have 3/8, and then I have to add 1/2. I can see that they do not have the same denominator. So I need to ask myself, can I rename one of these fractions? Can I rename them, one of them or both of them, so that they have the same denominator? Can I write another fraction for them that would still be equivalent? Well, I know that 1/2 can be separated up into eighths, and I know it's going to equal 4/8. I can see here that it's true. Since I know that 1/2 is the same thing as 4/8, I can rewrite it as 4/8. So 1/2 is equal to 4/8. The other part of my problem was 3/8. So now my two fractions have common denominators, and I can combine that. 3/8 plus 4/8 more is 7/8. Bottom number stays the same. All right, so let's draw that without these fraction models. Okay, I know I have 3/8. And then I'm going to draw 1/2. Now I know my 1/2 renames into 4/8. So I'm going to split this into 4 equal parts underneath, and I'm going to draw my eighths under here to say, hey, I know that 1/2 is equal to 4/8. So I'm going to essentially rename it. I'm renaming with an equivalent fraction. So now I can combine my two parts as common denominators. Here it says, how did you combine 3/8 and 1/2 to help you find how much Marley and Jackie saved? Okay, well, what did we do? We renamed one-half to 4/8. Then we could add the 3/8 to it. Okay, then it asks us to write an equation to model our solution. Well, one of the kids had 3/8. They combined it with the other kid who had 1/2, and altogether we said that equals 7/8. All right, now you can look at this too, and you can see, hey, we just didn't say 3 plus 1 is 7 and 8 plus 2 is 8. All right, we had to do some figuring and thinking through that up here in order to find out what that answer was. Okay, and it asks us, how could you have solved this problem in another way? Well, we could have drawn a circle instead of the bars, and we could have said, okay, here's the 1/2 that Jackie saved, and then the 3/8. How could we show the eighths? Well, here's the part that the half, but if I was going to break this into eighths, I'd have to do this, 8 equal parts. All right, I still have my 1/2 shaded over here, but now you can see it's 4/8. Then I'm going to shade in 3/8 more, 1/8, that's 1, 2, 3/8. All right, now if I count up the whole thing, I can see that 7/8 is shaded. And that shows me the same thing. My 1/2 over here plus my 3/8 over here gives me 7/8. All right, let's go to the next page. Okay, so this is page 131. And before I even read this problem, I really like to look at the question that's being asked so I can get my mind thinking about what kind of question is this. And I think this is a great strategy that you should use too. So even before I read it, I can see, oh, this is asking me how much trail mix does he have left? And even without reading anything else, I know that we're looking for how much somebody has left of something. So that means they started out with a whole amount. They had a chunk of something, and then some of it got taken away. And then whatever was left over was what we're finding out. And so I know, even before I read the story problem, that this is a subtraction problem. Now I want to read the problem to get my details. What do I know? Pedro takes 1/2 pound of trail mix on his hike. During the hike, he eats 1/4 pound of the trail mix. How much trail mix does he have left? Okay, and so that is a perfect example of a subtraction problem, as I suspected. So we start out with a total amount. He ate some of it, so some of it went away, subtracted out a part of it. And so we're finding that other part that's left over. So this is that part total model that we can make here. All right, so what is my total? So this is going to help me write my equation. I know the total. He had a half of a pound. He took away part of it, so part of it got taken away right here. How much got taken away? 1/4. So I know whatever this amount is that's left over will be my answer. So here's my total, 1/2, subtract the 1/4, and it's going to equal the other part that's missing. All right, how can I use fraction strips to represent the situation? Well, I can represent this as the total. All right, now when I go to put the 1/4, what do I do with this 1/4? I'm not going to add it to the end. I'm not just going to put it here on the end because that looks like an addition problem, this plus that. What needs to happen is I need to compare it underneath and say that much has to be taken away. So if I wanted to draw a line on here and X that out, or I could lay this right on top and say, okay, that much has to get gone. So this much over here is my answer. All right, but how do I know how much this is? How do I know how big how much is this equal to? Okay, well, I know that 1/4 plus another 1/4 is equal to 1/2.
4 + 1 divided by 4 is 4.25.
See, Google's going to help me out here, but she got the wrong answer. She's giving me decimal answers. All right, so I know that I'm starting out with a half. I'm taking away 1/4 of it. So how much is going to be left? 1/4. All right, well, what does that story look like in a math problem? All right, well, that renaming is going to happen again. All right, I'm going to draw that model, and I want you to draw the model too. You probably didn't draw all this, so let's use this space right over here to draw it. I'm going to draw my 1/2. And I know that I'm going to take away 1/4 of it. So I'm going to just say, this is 1/4. And I need to take that away. Okay, and so I usually represent that by Xing it out. And I want to know how much is this. Well, I know that 1/4 and 1/4 is equal to 1/2. So 1/2 minus 1/4 is going to equal 1/4. All right, so essentially what I'm doing is I'm taking that 1/2 and I'm saying that is equal to 2/4. 1/2 can be renamed to 2/4. And then I'm going to take away one of the fourths. And when I rename it, I see I have common denominators, same size piece. So I can say 2/4 minus 1/4 equals 1/4. So what fractions strip pieces can you use to represent the amount of trail mix he has left? Well, I can use the 1/4 size. Lastly, we need to write an equation to model the amount of the trail mix he has left. So the equation is 2/4 minus the 1/4 equals 1/4. Okay, on the turn and talk, it says, suppose Pedro had 3/4 of a trail mix at the start of the hike and he eats 1/3 of a pound. How can you find the amount of trail mix he has left using fraction strips? How does this fraction model compare to the one you used in the problem above? All right, well, we know that he's going to start out, instead of the 1/2 a pound, he's going to have 3/4 of a pound. And we're going to take away 1/3 of a pound. So the problem I need to model is going to be 3/4 minus 1/3 equals the part that's left over. All right, now this is a little bit trickier of a problem because up here we started out with a number 1/2, and we already knew I could rewrite 1/2 with 2/4 because most of us already know that equivalent fraction. 2/4 is equal to 1/2. But down here I'm starting out with 3/4, and I'm taking away a third. So let's take a look at this with the fraction bars. There's our 3/4, and we want to take away 1/3. When I look at this problem, I can see that I'm not going to be able to rename my 1/3. I'm not going to be able to rename it with fourths because I can see that 1/4 and 1/3, 1/3 doesn't divide up into fourths evenly. So I'm not going to be able to rename it as a fourth. And I cannot name my fourths as thirds. So I have to find a whole nother fraction that I could rename this with. And so what I would end up doing is renaming with a different size fraction piece. I can see that I can rename 1/3. I can rename 1/3 as 4/12. Okay, and that's because I can divide my thirds up into 12ths, and I can also divide my fourths up into 12ths. All right, so I think I don't have enough of the 12ths, but let me just do 2 of them. All right, I can see that 1/4 is equal to 3/12. Another fourth is equal to 3 more 12ths. And then that last fourth is equal to 3 more. So I'm going to have to rename my 3/4. I'm going to have to rename it as 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have to rename it as 9/12. So right here, I'm going to go to my 3/4, and I'm going to rename it as 9/12. So I'm just going to say 9/12 underneath here. All right, there's my equivalent fraction, 9/12. Now I'm going to have to take away 1/3. Well, I can't take thirds away from 12ths, so I'm going to have to rename my 1/3. And I can rename it as 12ths also. All right, so I can see that 1/3 is equal to 4/12. So if I have 9/12 and I take away 4/12 from it, I'm going to have 5 of the 12ths left. So this is a little bit more complicated computation here just because I didn't know immediately what it would be as an equivalent fraction. I had to change both of my fractions, not just one of them. Okay, let's look at check understanding. Okay, I've already underlined the question. How far is the waterfall from the nature center? So I want to start thinking, they give the waterfall distance right over here is 1/12 of a mile, but it says how far is the waterfall from the nature center? All right, so I'm going to have to be combining in here because I know we've got a 1/12 of a mile. We're going to have to add it to however far it takes to get to the nature center. And so that sounds like I'm going to be combining things in this question. So let's get our details from the rest of the problem. Claudia starts at the nature center and walks half a mile along a trail to this signpost. All right, so I know that she has walked a half a mile already. And then it says the waterfall is 1/12 of a mile from here. So I know she's walked a half a mile. And then how far is the waterfall from the nature center? So here she started out the nature center. She walked a half a mile. She saw the signpost. It's 1/12 of a mile more. So now to know how far it is going to be from one point to the last point, I'm going to have to add these two together. 1/2 plus 1/12. So I'm going to, first of all, I'm going to write my equation. 1/2 plus my 1/12 is going to give me my total amount, the total distance. So this part plus this part is going to equal my total for the sum. How can I use fraction strips to represent the distance? All right, well, let's draw to show your thinking. Well, I'm going to draw the strip that equals 1/2. And then I'm going to add a 12th more over here. Okay, now, halves are pretty easy to think about. And I'm wondering, I know I'm going to need, before I can add these together, I'm going to need a common denominator. I need the same size piece. Can I rewrite 1/2? Can I write an equivalent fraction that's equal to 1/2, except have a 12 at the bottom? Well, I know I can. I know that 6/12. I know that 1/2 is equal to 6/12. I know that this is true. So what I'm going to do is I'm going to come over here and I'm going to show that I'm going to divide this up into 6 equal parts, and each of those parts is going to be a 12. And I did this because I know that 1/2 is equal to 6/12. So I'm going to rename it as 6/12. And then this piece can stay the same. I'm just going to bring it down. And the same size piece, and I can combine them. 6/12 plus one more 12 is 7/12 of a mile. All right, so it was 7/12 of a mile from the nature center. Write an equation to show the distance from the nature center to the waterfall. What is the distance? All right, well, we can write the original equation. 1/2 plus 1/12, and we know it's equal to 7/12. Now our figuring out isn't here. We just wrote the equation and the answer. Here's all of our figuring out. All right, let's go on to the last part of this. All right, so here we have this information. The questions are down here. How long is the part of the stake that is above the ground? So obviously she's driving a stake into the ground. You know what a stake is. A stake is something to hold the edge of a tent in. It's like a stick. How long is the part of the stake that's above the ground? So I know you've got a stake. That's the total length. She beats it into the ground. Some of it's underground, some of it's above ground. Luna hammers her stake into the ground for a tent. The stake is 7/8 of a foot long. She hammers 3/4 of a foot into the ground. So I know the total is 7/8. The part she hammers into the ground is 3/4. So I'm going to take that away because it's got knocked underground. And I want to know how much is left. That part, I'm trying to find out what's left. I can see that these two fractions do not have common denominators if they're not the same size piece. I want to represent 7/8. And I think I'm going to do this in a circle this time. So draw a circle. We're going to divide it into 8 equal parts. Okay, divide it in half. Divide it into fourths. Divide those fourths in half again. And that's going to make eighths. I'm going to lightly shade in 7 of them. And that means you are shading in 7 of them. All right, and since I am taking away 3/4, I can see that 3/4 of this. Can everybody see where 3/4 would be? I'm going to mark back over it again. And I'm just making the heavier part there, I'm making it into fourths. So you see how this is 1, 2, 3, 4 equal parts, I'm going to mark out 3/4 of it. And I can see how much is left right there. Only 1/8. So I can see that 7/8 minus 3/4 is equal to 1/8. So how long is the part of the stake that is above the ground? It is 1/8 of a foot. Draw to represent how you solve the problem. There it is, baby. Write an equation to model the problem. Well, our equation was 7/8 minus the 3/4 is equal to 1/8 of a foot. Okay, this part doesn't show the working it out. That just shows the original model or equation. Let's go to number 3. Tyler's cell phone has 7/8 of its charge left at the start of a hike and 1/5 at the end. All right, so here's our question. How much of the phone's charge is used during the hike? Well, this too is a subtraction problem. We know that he started out with this total. I'll draw this model right here. 7/10 of it was charged. And he used up part of it. He used up part of it right here. He used up this much. And I know that 1/5 was left at the end. All right, so this is the part that's missing. A part of it is missing. Here's the total, here's a part, here's a part. So I know that if I say 7/10 minus 1/5, it's going to tell me what this other part is. All right, so my equation that I'm solving, I'm going to draw the work right here, but I'm going to write my equation right here. 7/10 minus 1/5 will tell me the part that I need to know. All right, it asks here, how much of the phone's charge is used? Well, that's what we're going to determine because we don't know. We just know how much is left. All right, well, I'm going to start out with 7/10. So obviously I need 7 of the 10s. 1, 2, 3, 4, 5, 6, 7. I need to take away 1/5. Okay, so I'm just going to compare it and see just how do these compare. Well, that's convenient. I can see that 1/5 is the same as 2/10. So I can literally lay this up there. 1/5 is equal to 2/10. So if I take away that much, it's going to leave 1, 2, 3, 4, 5. It's going to leave 5/10. So I know that 7/10 minus 1/5 is equal to 5/10. All right, well, what did we just do there? Well, we took the 7/10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got too many of them. Let's scribble that one out. All right, I'm going to shade in my 7/10. 1, 2, 3, 4, 5, 6, 7. That goes to here. All right, there's my 7/10. And I said that 1/5 was equal to 2/10. So I'm going to match it up right there and say that's 1/5. And so if I take away this amount, it's going to leave 5/10. Okay, so what happened here? I have the 7/10. I kept that the same. But I had to rename my 1/5. I renamed it to 2/10. So that's really what I took away. I had to rename my 1/5. I renamed it is 2/10. 7/10 minus the 2/10 is equal to 5/10. And you probably know 5/10 is equal to a half. All right, so for my class, you will have all this filled out when you come to school tomorrow, and we're going to check it. You need to work in your freckle math, work on the base 10 problems, or going into the fractions. All right, good luck on that. See you Thursday.